Welcome to my channel again. How are you all? Great. So in this video, we are going to discuss about rational numbers. Rational numbers class 8 topic. So we'll discuss rational numbers in detail, its properties we will discuss over here. So let's begin about rational numbers. What are rational numbers? Let's see. So before starting rational numbers, we will discuss what are natural numbers and about whole numbers as well as about integers first of all. So let's see. Natural numbers. Natural numbers are those numbers which start from 1 and goes up to infinity. So the numbers which are starting from 1 actually, they are known as natural numbers. Whole numbers. Whole numbers are those numbers which starts from 0 and goes up to infinite. So 0, 1, 2, 3, 4 and up to infinite are natural numbers as well as whole numbers. So the numbers starting from 1 are natural numbers and the numbers starting from 0 are whole numbers. So the difference between natural numbers and whole numbers is of 0 only. Whole numbers consist 0 as well as all the natural numbers. So you may check here, natural numbers are the part of whole numbers. Let's see integers. So you can check the number line over here. In the middle, we are having 0, which is neither a positive or negative integer. So 0 is neither positive nor negative integer. 0 is just an integer. It's neither positive nor negative. But it's not like a 0 is not an integer. It is an integer, but it's not positive and not negative. Okay. So positive integers are like the natural numbers 1, 2, 3, 4 and so on. Negative integers -1, -2, -3 and so on. And 0, a simple integer. We can't define its sign. So the numbers which are like negative, positive as well as 0 are known as integers. So you might have seen lift. In the lift we use the numbers like 0, 1, 2, 3, 4 and for going in the basement we use -1, 2, 3, -1, -2 like that. So all these numbers are known as integers. So now we can say natural numbers are part of whole numbers. Natural numbers are part of integers as well. And whole numbers are part of integers. Okay. Let's move ahead. Rational numbers. Rational numbers, if you check out, rational numbers are those numbers which are in the form of P by Q. P by Q means fractional form. So the numbers which are in a form of fraction and the condition is the denominator, that is Q value, should not be equals to 0. So rational numbers are those numbers which are in the form of fraction, but the denominator should not be equals to 0. Okay, and the numerator can be any integer, like it can be positive integer, it can be 0, it can be negative integer. So we can say all the integers are rational numbers, because if I'll talk about an integer like 2, so 2 we can write as 2 upon 1 and that is a rational number. Okay, because the denominator is not equals to 0. So all the integers are rational numbers basically. So just make sure in rational numbers, denominator should not be equals to 0. It should be of the form P by Q. P and Q are integers, but Q should not be equals to 0. So you may check here in the surrounding of this bubble kind of shape. So there are numbers written. Okay, so they are known as rational numbers because they can be represented in the form of P by Q. Do you know 0 is a special rational number? It can be written as 0 upon any digit, means any integer. So 0 is also a special rational number because we can write it in the form of P by Q. 0 upon 5, 0 upon 3, 0 upon any number. Okay, 0 upon -3. So 0 is a special rational number. It's not like 0 is not a rational number. It is a special rational number. Okay, because we can write it with any integer except 0. So here we can say natural numbers are part of whole numbers. Natural numbers are part of integers and natural numbers are part of rational numbers as well. Similarly, whole numbers are part of integers. Whole numbers are part of rational numbers also. And similarly, integers are part of rational numbers. Okay. I hope this part is clear to all of you. Now let's move ahead. We will discuss properties of rational numbers. We are going to discuss three properties over here: closure property, commutative property, and associative property. So let's move ahead one by one. So first property is closure property. So closure properties, these are the properties for integers as well, we can say. Like if we are following the closure property for integer, that means it's a property of integers. If we are following it for rational numbers, then it is a property of rational numbers. So in the case of integers, in the case of whole numbers, natural numbers, rational numbers, we have to follow these properties only. But it depends like what kind of numbers we are taking. If we are taking whole numbers, then it would become the property of whole number. If we are taking natural number, then it would become the property of natural number. Similarly, if we will take integers, then it would become the property of integers. And similarly for rational numbers as well. So let's move ahead one by one. Closure property. Closure property means like when we apply the closure property, like suppose I'm considering whole numbers. Okay, I'll just elaborate it to you so that you can understand. Suppose I'm taking whole numbers. I'm taking 3 and 2. So, and I want to apply a mathematical operation over here. I want to apply this addition mathematical operation. Okay. So if I'm doing 3 plus 2. So 3 is a whole number, 2 is a whole number. Now we will check the answer of it. 3 plus 2 is 5. So the answer would also be a whole number. And we can say this 5 is also a whole number. So if answer is also coming with the same category like in which we were taking the numbers, so then we can say closure property is following over there. So 3 is a whole number, 2 is a whole number, 5 is also a whole number. So closure property is satisfying in the case of addition, in the case of whole numbers. Okay. So this way we can check the whole numbers property basically, like closure property in the case of whole numbers, natural numbers, or integers, etc. Okay, let's move ahead now. So we'll discuss it one by one by taking example. Closure property will check for whole numbers and natural numbers. Okay, I want to tell you one thing. Whatever numbers you will take, I just took two numbers just in the previous part, 3 and 2. 3 and 2 are whole numbers as well as natural numbers also, right? So if this property is following for whole numbers, then that means it is following for natural numbers as well. So whatever examples, the numbers you are taking in the example basically, that are whole numbers also and that are natural number also. So the result would be same in both the cases. Let's see. So we will check the closure property with all four mathematical operations, that is addition, subtraction, multiplication, and division. So let's talk about addition first of all. So addition will take two whole numbers. So you can take 0 as well. So suppose I'm taking 0. Okay, 0 plus any other whole number, 7. Okay, you can take any one. So 0 is a whole number, 7 is a whole number, and the answer of it would be 7. So the 7 is also a whole number. That means whole numbers are closed under addition. Are closed under addition means, closed means it's following the closure property. Okay. Now subtraction. So again the same numbers I'll take, 0 and 7. So 0 minus 7 because it is subtraction case. Okay. So 0 minus 7 would be minus 7. But minus 7 is not a whole number. So here in this case, the result is not appearing as a whole number. That means closure property is not following under subtraction. So we can say whole numbers are not closed under subtraction. Understood? So the result should be of the same category, but here the result is not a whole number. 0 is a whole number, 7 is a whole number. But when we are subtracting both, the result is not a whole number. That's the reason whole numbers are not closed under subtraction. Okay, let's move ahead now. So same numbers again, 0, 7. Now we will check multiplication. 0 multiplied by any number is 0. So again the answer is a whole number. That means whole numbers are closed under multiplication. So now till now addition and multiplication are closed basically. Okay. They are following the closure property. Let's check the last mathematical operation. So again, we will take the same numbers 0 and 7 and we will follow the division criteria here. Okay. So 0 divided by any number is 0. So here you will see in this case it is closed. But if we will take any other number a part of 0 like this 5, 6 or any other number, then 5 upon 6 is not a whole number. In this case, it's not following. If I'll take the number like this, instead of 0 and 7, if I'll take 7 divided by 0, then also it's not following because any number divided by 0 is not defined. Okay, so that means whole number is not appearing. So if we are saying whole numbers are closed, means if we are saying closed, that means in each and every case it should be closed. If any of the cases appearing like in which it's not following, in that case we can say it's not closed. Doesn't matter, it's following the other cases. But if it is not following either even a single example now, then in that case it's not closed. Okay, so here in the division case you can see this is not following, this is not following, and so many examples are there. So division, like whole numbers are not closed under division. So I hope this part is clear. If any doubts, you may ask me from in the comment box as well. So same way we can say for natural numbers also. So in the case of natural numbers, don't take 0. You can take any other numbers as I took over here. Over here I took 5 is a natural number, 7 is a natural number, 12 is a natural number. So it is closed. 5 is a natural number, 7 is a natural number, and the result is not a natural number. So it is not closed. 5 is a natural number, 4 is a natural number, result is also a natural number. So it is closed. 5 is a natural number, 6 is a natural number, but 5 upon 6 is not a natural number, so not closed. So this way you may check out if the answer is also appearing of the same category, then in that case we can say according to our answer, like if answer is appearing same, like of the same category, that means we can say it's following the closure property. Otherwise, it's not following the closure property. Okay, so let's move ahead now. We'll see the closure property for integers. For integers. So in the case of integers, I just told you integers consist positive numbers, negative numbers, as well as 0. So you may take here 0 as well. You may take here positive numbers. You may take here negative numbers. Okay. So you check here. Suppose I'll take negative number also. The examples I've already discussed, like it's written, but I'll take any other example part of this. So suppose I'm taking -2 and 3. Okay, so I took one negative and one positive number. So I'm following addition here. So -2n is an integer, 3 is an integer. Let's see the result. -2 plus 3, you may check. So in the case of integers, now what you have to do, if two different signs are appearing, minus plus or plus minus, then in that case we do subtraction of the numbers. Okay, but if the same signs are appearing like minus minus and plus plus, then we do addition of numbers. So integers now I have discussed in one of my video. I'll just share the link in the description box related to that video about integers. You may see that video and it would clear your concepts related to integers, like how to do addition, what are integers, whatever. Okay, you may check that video and clear your concept from there about integers. So this way we do. So here -2 plus 3 would be 1, and 1 is also an integer. That means integers are closed under addition. Now let's see the subtraction. The same numbers I'll take -2, 3. Now we have to follow subtraction. So -2 minus 3 would be -5. Again, -5 is an integer. Mark my words here, -5 is an integer. So in this case, integers would be closed under subtraction. Okay? In other cases, they were not closing, because if we will consider the natural numbers or whole numbers case now, the answer was not appearing of the same category, but here the answer is appearing of the same category as an integer. So subtraction is following the closure property in the case of integers. Okay, let's move ahead now. This is important here. Multiplication. -2, 3, let's multiply both. 3 2s are 6 and 2 is of negative, like negative number. So it would be minus 6. Again, minus 6 integer, so it would be closed. Minus 2, 3, we will divide. So if we will divide both, it would be minus 2 upon 3. This is not an integer, minus 2 upon 3, right? So not closed. So in the case of integers, integers are closed under addition, subtraction, and multiplication only. So till now, whatever we have discussed, we'll revise quickly. In the case of whole numbers are closed under addition and multiplication. Natural numbers are closed under addition and multiplication again. Integers are closed under addition, subtraction, and multiplication. Okay, let's talk about rational numbers closure property. Okay, if you are in class 7, you have to talk about closure property till here. Whole number, natural number, and integers. If you are in class 8, then you have to talk about this closure property up to rational numbers, this one more part. Okay, let's see. So addition. Addition, we are taking two rational numbers here, 1 by 5 and 2 by 5. This one, if we will add both, we will get 3 by 5. This is also a rational number. So that means rational numbers are closed under addition. Now another, 4 by 5 is a rational number, 1 by 5 is a rational number. We are subtracting it and we are getting the answer as 3 by 5, which is also a rational number. So see, closure property. In the case of rational numbers also, it's following subtraction. Okay, so rational numbers are closed under subtraction also. Similar like integers, it were following na. Similarly for rational numbers as well. Okay, multiplication. This is a rational number because rational numbers also can be negative. Why? Because integers are part of rational numbers, right? Integers are negative also. So if integers are negative, rational numbers also can be negative. But in rational numbers, denominator can be any number a part of 0. Okay. So here minus 5 upon 6 is a rational number. 1 upon 5 is a rational number. If we will multiply both, we will get minus 5 upon 30, which is also a rational number. So it is also closed under multiplication. Then let's check the division. A number divided by 0, I just told you, not defined. So 4 upon 5 is a rational number. 0 is also a rational number. But if you take a number divided by 0, that is not defined. So that means it's not closed. Okay, because not defined means we are not getting the answer as rational number, right? So rational numbers are closed under addition, subtraction, and multiplication. So let's revise quickly again. Whole numbers are closed under addition and multiplication. Natural numbers are closed under addition and multiplication again. Integers are closed under addition, subtraction, multiplication. Rational numbers are closed under addition, subtraction, multiplication. So if you're finding the word closed, that means they're talking about closure property. Let's move ahead to the next property now. Commutative property. Commutative property states that the change in the order of two numbers, if you're changing the order of two numbers in an addition or multiplication operation, and does not change the sum of the sum or the product, basically. Like if we are applying commutative property in addition of numbers, then it won't change the answer when we will change its order also. I'll tell with an example, then it would be clear to you in more detail. So this follows addition and multiplication. Let's see how commutative property works basically. So in commutative property now, we will take two numbers. So we are talking about whole numbers and natural numbers. Okay, so I'll take natural numbers only because natural numbers are also whole numbers, right? So I'm just taking 3 and 6. So 3 is my number, 6 is my number. If we will add both, we'll get 9 as result, right? Now change the order. Change the order means instead of 3 plus 6, we will do 6 plus 3. Okay, so 3 plus 6 ke jagah we'll do 6 plus 3. So 6 plus 3 is also giving 9. So we are getting the same response. See, 9, 9 after changing the order. So in commutative property, we change the order of numbers and then we solve them. If we will get the same answer, then we can say whole numbers are commutative in the case of addition. Okay, let's move ahead. Whole numbers as well as natural numbers because they follow the same kind of thing. Now, 3 is my number, 6 is my number. We are following subtraction. Answer would be -3. Now change the order. A part of 3 minus 6, we will do 6 minus 3. So 6 minus 3 is 3. Here you can check it's -3. This is 3. That means the answer is changing after changing the order. So subtraction is not commutative for whole numbers. Let's see multiplication. 3 multiplied by 6, 18. 6 multiplied by 3, 18. Same, it's following. 3 divided by 6, 6 divided by 3. Okay, 3 divided by 6 is 3 divided by 6. That means 1 by 2, right? 3 ones are 3, 3 twos are 6. 1 by 2. And 6 divided by 3 is 6 divided by 3. That means 2 upon 1, that is 2 only. So in the first case, we are getting the answer as 1 by 2. In the next case, we are getting the answer as 2. Both are different. So if they are different, that means whole numbers and natural numbers are not commutative for division. So whole numbers and natural numbers are commutative for addition and multiplication only. I hope commutative property is clear. Now we will see this property for integers and rational numbers. Same response you will get for integers and rational numbers again, because as natural numbers are part of whole numbers, similarly integers are also part of rational numbers. Okay, so if we are taking 5 and 2 as our numbers, 5 is our integer, 5 is a rational number as well, 2 is an integer, 2 is a rational number as well, right? So 5 plus 2, 7. Change the order. 2 plus 5, 7. Same response, that means commutative. Okay. -5 now we are taking, and 7 we are taking. Two numbers, -5 and 7, and we are checking the subtraction. So -5 is an integer, 7 is an integer. If you will check rational number, yes, they are rational numbers as well. Subtract both. -5 minus 7 would be -12. Now 7, now change the order basically. So instead of -5, 7, we'll take 7 and -5. Okay, and then we will follow subtraction in between. So minus would become plus. So it would be 7 plus 5. 7 plus 5 is 12. So this is 12. This is -12. They are not equal. So not commutative. Let's check the multiplication. Numbers are -5 and 4. Multiply -20. Change the order. 4 multiplied by -5. Sorry, it should be -5 here. 4 multiplied by -5, -20. Okay. So same response, commutative. Now let's check the division. -5 and 6. So -5 upon 6, this would be, and this would be 6 upon -5 after changing the order. You may check the answers are not same, so not commutative. So from here we can say whole numbers, natural numbers, integers, rational numbers, all are commutative for addition and multiplication only. Okay? All are commutative for addition and multiplication. Just change this part now. This is -5. This is -5. Hai na? Just correct it when you will note down. Okay. So I'm saying commutative property के case में whole numbers, natural numbers, integers, rational numbers, all are commutative for addition and multiplication only. But in the case of closure property, integers and rational numbers were closing under addition, multiplication as well as subtraction also. Okay? Okay, let's move ahead now. Associative property. The associative property states that the sum or the product of 3 or more numbers does not change if they are grouped in a different way. Grouped. Grouped, whenever you will find this word grouped, that means they're talking about associative property. Okay, if you will find the word closed, closure property. If you will find the word grouped, associative property. If you will find the word commute, 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 then it is commutative property. So let's see associative property. What does it mean? What does it mean? Okay, commutative property. We'll check the meaning of it first of all. So you may check here. Just a second. Okay, so we are taking 3 numbers here. First number is 10. I'm taking 3 examples. I'll discuss the first example. So we are having the first number 10, second number 7, third number 5. Now what we will do in the associative property now, we'll group them. How? Like I'll write three numbers, whatever I'm taking, one time and one more time. And now we are following addition here. We are checking the mathematical operation addition. So we'll put addition sign in between. Now we will do grouping. So grouping, how we will do? First two numbers here and here last two numbers. So how we will solve them? First we will solve this bracket 10 plus 7, 17 plus 5, the remaining number 17 plus 5, 22. Okay. Now in this case 10 plus would be same because we are grouping 7 and 5 together. So we will solve them first. So 7 plus 5, 12. 10 plus 12, again 22. So we are getting the same answer. As we were getting the same answer in commutative now, similarly in associative also we are going to check the same thing, same answer. The difference is in associative we do grouping of numbers. So 20 to 22, same answer. That means associative property is following under addition. So you may check the other examples also. 5 plus 6, 11, 11 plus 21, 32. Similarly here 6 plus 21 we will solve first of all. So it's 27 and 5 plus 27 is 32. Same answer? Yes. So the third example as well. So this way you can write as many examples as you want. Whatever examples are coming in your mind, you can apply that one. Okay. So this is associative property. So let's apply it now. For whole numbers and natural numbers is same as I discussed like just 1 minute back. I took three numbers, this one, 10, 3, 5, whatever I was discussing just now. Same case here as well. Any numbers you may take, you can apply addition part over there and that would give you the same result, and that is associative. Okay, that means whole numbers are associative under addition. Now let's see the subtraction part. So here we are taking the number 5. I'll take the another color. Okay, we are taking the number 5, number 7, number 2. So we are having three numbers, 5, 7, 2. 5, 7, 2. Again 5, 7, 2. We have to do subtraction. We'll group first two numbers here. We'll group last two numbers here. Okay, 5 minus 7. First of all, we'll solve. 5 minus 7 is minus 2. And again, minus 2 is left over, which is minus 4. Now, in this, we'll solve this bracket. So 5 minus 7 minus 2 is 5. 5 minus 5 is 0. So you can see the answers are not same. That means not associative. Okay. Now let's move ahead. We'll see the multiplication part. Again, we will take the three numbers. Just a second. Okay. Again, we'll take the three numbers 5, 4, 2, 5, 4, 2. Okay. We'll do grouping. Okay. Here we are doing the grouping of last two numbers and then the first two numbers. Doesn't matter. Anyway, you can do. So 5 multiply 4 multiply 2. 5 multiply 4 multiply 2. Let's group first two numbers. Let's group last two numbers. 5 multiplied by 4 is 20. Multiply by 2, that is 40. Here 5 multiply by 8. 5 8s are 40. So we are getting the same answer. That means whole numbers and natural numbers are associative under multiplication. Let's see division now. 5, 6, 2 we are taking as the numbers. So let me just erase this part first of all so that I'll describe the division part to you. Okay, let's move ahead. 5, 6, 2. So 5, 6, 2 division. We are going to check 5, 6 and 2 division. We'll group 5 and 6 here. We'll group 6 and 2 here. 5 divided by 6 is 5 by 6 divided by 2. This is 5 divided by 6 by 2. Okay, 5 and 6 we can't cancel. So it's a fraction. So in the case of fraction, what we do now, division को will convert into multiplication. और जब हम division को multiplication में convert करते हैं, then the next number written after it would be reciprocal. So 2 का reciprocal is 1 by 2. ठीक है? Here also 5 divided by 6 and 2 can be cancelled out. 2 3s are 6. So 5 divided by 3. So here if you check, it's 5 multiplied by 1, 5. 6 multiplied by 2 is 12. And here this is 5 upon 3. So the answers are not same. So not associative. Okay. So whole numbers and natural numbers are associative under addition and multiplication. Now, let's move ahead. We will see integers part. I'm repeating again. If you are a class 7 student, then do it up to integers only. If you are a class 8 student, then do up to rational numbers. Okay, let's move ahead. So don't put the heading rational numbers if you are a class 7 student. Now, integers and rational numbers. Integers are part of rational numbers, so it would follow the same thing. So I'll just discuss this part only, and that would be the case of integers and rational numbers both. Okay, so here we are taking the numbers -2, 3, -4. Okay, -2, 3, -4. Again, -2, 3, -4. We will check the addition. So we'll put plus sign. See, two signs are appearing together, so इस number को bracket में रखेंगे, ठीक है? Now plus again it would in brackets. Now these are three numbers only, and we have put the addition mathematical operation. Now we'll do grouping. So grouping के लिए what we'll do, we'll put these two numbers in one group, and we'll put last two numbers here in one group. Now let's solve. -2 plus 3 is 1. Plus minus is -4. 1 minus 4 is -3. Now -2 same. 3 plus minus is minus. 3 minus 4. So 3 minus 4 is -1. So -2 plus -1. So here plus minus. So plus minus is minus. So -2 -1, which is -3. Same result. That means they are associative. So integers and rational numbers are associative under addition. Same way you may check for subtraction. Suppose I'm taking the same example. What I'll do, I'll just replace these addition symbols with subtraction symbol. Okay. So the numbers are same, -2, 3 and -4. And I'm checking subtraction part now. Don't confuse. Now I'm checking for subtraction. Okay. Minus, 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 minus. Now let's solve the first bracket. So if you solve the first bracket, -2 minus 3 is -5, minus minus plus 4. -5 plus 4 is -1. Now in this part, -2 same. And let's solve this bracket, minus minus plus. So it would be 3 plus 4. -2 minus 7. -2 minus 7 is -9. Answers are not same. They are not equal. That means subtraction is not associative for integers and rational numbers. Okay. Now, we will see multiplication part. So I'll just erase it quickly. Then I'll tell you the multiplication. Again, we are going to take the three numbers. So here we are taking 5, -7 and -8. 5, -7, -8. Any numbers you may take of your own choice. 5, -7, -8. So first number, second number, third number. Okay. First, second, third. Three numbers we are taking here. Now what we'll do, we'll check the multiplication. So we'll put multiply here. Okay, let's group them. So which numbers we will group? First two numbers. Here, last two numbers. Okay, now let's solve. 5 multiplied by -7. That is -35. 5 7s are 35 and it's negative. Multiplied by -8. Okay, 35 multiplied by 8. Okay, how much it would be? Quickly solve it and tell me. How much would be 35 multiplied by 8? Yes, 35 multiplied by 8 is 280. So this is 280. And this is minus minus, so it would be plus. Now, 5 multiply same. We'll solve this bracket first of all. So -7 -8. So let's multiply 7 8 first. 7 8s are 56. Minus minus plus. Okay. Now 5 multiplied by 56. So 5 multiplied by 56 is 280 again. So you're checking the answers are coming same. That means multiplication is associative. I hope this part is clear, right? Now we will check the division. So what I'll do, I'll just replace the multiplication part with division. Okay. So I'm going to check for division. Numbers are same. You may take the numbers of your own choice. I'm taking the same numbers here. Okay, let's apply. 5 divided by minus 7. 5 divided by minus 7. You may write minus here as well, here as well. Okay. Now divided by minus 8. Here 5 divided same. Now we'll solve this bracket first of all. Minus 7 divided by minus 8. Okay. So fraction may whenever division is there, I just told you that what we'll do reciprocal. Why? Because we'll convert division into multiplication. So minus 5 upon 7 would be same. Divide would become multiply. And the reciprocal of minus 8 is 1 upon minus 8. Now here 5 divide would become multiply. Reciprocal of minus 7 upon minus 8 is minus 8 upon minus 7. Now let's solve. Minus 5 into 1, minus 5. 7 into 8, 56 and minus का. ठीक है? So minus minus cancel. The answer is 5 upon 56 here. Now in this case, minus minus cancel. 5 8s are 40 upon 7. So you may check this is 40 upon 7. This is 5 upon 56. That means not associative. So the answers are not coming same. That means not associative. So integers, whole numbers also associative under addition and addition and multiplication. Okay. So let's revise quickly whatever we had discussed so far. Closure property ka case if we'll take closure property. I'm taking the case of whole numbers and natural numbers. So whole numbers and natural numbers are closed under addition and multiplication. Integers and rational numbers, both integers and rational numbers are closed under addition, subtraction and multiplication. Commutative property. Whole numbers, natural numbers, integers, rational numbers, all are commutative for addition and multiplication only. Case of associative property. Whole numbers, natural numbers, integers, rational numbers, all are associative for addition and multiplication only. So everything is following this addition and multiplication except in closure property, integers and rational numbers, they follow subtraction as well. I told you why that time. Okay. So this is about closure property, commutative property and associative property. Let's see additive identity now. So the additive identity property states like for any number, if we are adding that number with 0, we'll get the same result as the answer. Let's see the example. 7 plus 0, 7. Similarly, 46,346 plus 0 is 46,346. So in short, we can say any number, if we will add with 0, that would give the same result as the number itself. Multiplicative identity. The multiplicative identity property states like for any number, if you will multiply with 1, any number multiplied by 1, the product would be the number itself. So additive identity में number कैसे आ रहा था वही same by adding 0 into it. In multiplicative identity, if we'll multiply 1, then in that case we will get the same number. Okay, this is multiplicative identity. Negative of a number or additive inverse. So what is, if question is saying now what is the another name of negative of a number, so you will say the another name is additive inverse and vice versa. Okay, so negative of a number is additive inverse only. What is the meaning of additive inverse? Additive inverse is that like if I'm giving any number, suppose 2. So 2 में हम क्या add करें? What we add in that number 2 so that we will get the answer as 0. So 2 में क्या plus करें कि answer 0 आ जाए? So in number 2 we will add minus 2. Only then we would get the answer as 0. So additive inverse में आपको कुछ नहीं करना. Whatever number is given, same number you will write with opposite mathematical operation. Means अगर plus है तो minus, minus है तो plus. So it is plus, so answer would be minus 2. If question is minus 2, then answer would be 2. Okay. So this way you are going to do additive inverse or negative of a number. You may check the examples here as well. -5 का additive inverse is 5. 14 का additive inverse is -14. Okay, let's move ahead. Reciprocal or multiplicative inverse. So the another name of multiplicative inverse is reciprocal. What you have to do here, multiplicative inverse means any number, if you will multiply it with its reciprocal, you will get the answer as 1. तो मतलब क्या हुआ कहने का, अगर किसी नंबर मतलब जैसे अगर मैंने 2 दिया तो 2 में मैं क्या मल्टीप्लाई करूं कि मुझे आंसर 1 मिल जाए. What shall I multiply in this number 2 so that I'll get the answer as 1? So इस 2 में I'll multiply 1 by 2, the reciprocal of it. Only then I would get the answer as 1. Why? Because 2 ones are 2 ones are cancel हो जाएंगे and it would give the answer as 1. So whenever the question is asking multiplicative inverse, आपको कुछ नहीं करना, only you have to do the reciprocal of the number. Suppose number is given as 3/5. So the multiplicative inverse of 3/5 would be 5/3. Only reciprocal. Okay? In additive inverse, change the sign only. In multiplicative inverse, just do the reciprocal. That was about today's video about the topic rational numbers as well as integers as well as whole numbers as well as natural numbers. You can take any number according to your class and can apply the properties, closure property, commutative property, and associative property over there, and all the mathematical operations, addition, subtraction, multiplication, or division. So check out the properties, and I hope this part is clear to all of you. If not clear, still you are having doubt, you may ask me in the comment box. And for upcoming like topics related to the chapters related to it, rational numbers and all, class 7 and class 8, and any other like student want. So I'll just update, I'll upload more videos according to my feasibility. Okay, so have a nice day. Bye bye.